Okay, so if we pick up where we left off, okay, the net energy system, remember that this is for maintenance and this is for production, okay? If you look back at this chart, okay, we're down here at the bottom, okay? So you already fed your animal. There was energy lost in feces, urine, and gases in the form of body heat, okay? So we're down to net energy for maintenance and then production, okay? So if we kind of work back up the diagram, okay, so we talked about that net energy. Now if we kind of work backwards and work back up to these different energy components, GE, DE, ME, and NE, okay? No, those are not state acronyms, okay? We have our gross energy, digestible energy, metabolizable energy, and net energy, okay? So your gross energy, again, at the top is the amount of the heat or energy released from complete burning of a feed sample, okay? And that's after that's at the very beginning, okay? So that's essentially the feed that you fed your animal, okay? Then from there, remember you lost energy from fecal energy, and it gets you to your digestible energy, okay? And then digestible energy minus the urine and gas is going to result in your metabolizable energy, okay? And then metabolizable energy minus your heat increment or your body heat energy requirement gets down to that net energy, okay? And that is the metabolizable energy minus the energy used for basically the metabolism of feed, okay? So again, that's just basically a text or a written version of that diagram from a couple slides ago, okay? So when you're balancing for rations, or if you're looking at a feed sample, a lot of times it'll be, it'll have that NE or that net energy, then it'll have a subscript, okay? And a subscript is basically a smaller letter down here, okay? And it'll be M for maintenance, G for gain, or L for lactation, okay? So remember, these are going to be basically the production components of net energy, okay? NEM is going to be for maintenance, and this gets a little bit confusing because this is not referring to the maintenance on that left-hand side of the chart. This is for maintenance after the maintenance component that was on that chart, okay? And this is important for balancing a ration for cow-calf, okay? Because you're trying to maintain that cow at her current body weight, okay? If she's at that current body weight, for her to continue to produce a calf but not overfeed her, okay? Or you want her to remain at a constant body weight, okay? While she's producing a fetus or, you know, making milk for that calf on her side, okay? Net energy for gain is going to be important for like feedlot situations, okay? Or like the swine industry, okay? So that's the amount of energy needed above maintenance in that ration so that they can gain in the feedlot, okay? And these typically will range anywhere from 48 to 64, and that's megacows per hundredweight, okay? So again, we're talking about that megacows, and I don't expect you to know much. If you take feeds and feedings next semester, we'll get a lot more detail into this information on this page. But for Intro to Animal Science, I just want you to be introduced to the idea, but that's kind of what we're talking about. So we have NEM for maintenance on a cow-calf, NEG for like feedlot type rations, or NEL for lactation, okay? And this would be very important for obviously the dairy cow industry, okay? And this is going to be, you know, how much energy is needed for that dairy cow to produce as much milk as possible. Okay, so hopefully that's just kind of an introduction to basic kind of nutrition, ration balancing information, okay? So when we talk about nutrition and feedstuffs and kind of what's available, I wanted to add this slide in about byproducts, okay? And some of you have probably heard of byproducts, especially if your family or friends are involved in the livestock industry, okay? But byproducts are essentially what's left over after the main component is taken out of the grain, okay? The first few that come to mind in this area would be like beet pulp, wet beet pulp. Okay, after they process the sugar beets, they get the sugar out, and that's obviously the main reason for producing sugar beets. Okay, they're left with a pulp product. Still really high in fiber, really high in energy for cattle rations. Okay, and so that's a great byproduct at a cheaper cost than buying, like, say, corn or something like that. Okay, corn or oats. In the Midwest, where they make a lot of ethanol, the byproduct that's available a lot is the distiller's grains. Okay, and that's going to be a byproduct after they've taken the ethanol out of the corn. Okay. The thing with byproducts is that typically you can find something that has a great nutrition composition, but it's at a more competitive cost than maybe your mainstream ingredients like the corn, oats, barley, stuff like that. Okay. The only thing is that you have to remember that this ration balancing is crucial when a variety of feedstuffs and byproducts are available. Okay. You can't just keep throwing in and changing things as things become available kind of at a whim. You want to make sure that you're meeting the animal's requirements. And again, that's where a nutritionist or taking some extra classes in feeds and feeding or livestock nutrition can be very beneficial to you in using those tools that are out there. Okay? And a lot of times what nutritionists will use is a least cost ration formulation. So they'll use kind of the ingredients that are available to you and come up with a thing that's going to cost the least amount but meet all the animal's requirements. Okay? It's very important in sustaining the livestock industry as more of these traditional feedstuffs are directed towards humans. Okay? Some other examples of byproducts are going to be, like we already talked about, the distiller's grains, the beet pulp. Some other things would be like wheat midds, cottonseed meal or cottonseed hulls, soybean hulls, stuff like that. Okay? So that's byproducts. I think that's the last slide on this PowerPoint. Okay? So we'll go ahead and continue into our next PowerPoint. Okay? So we just finished up proximate analysis, so we'll get into digestion and absorption. And this is going to be chapter 16 in your text. Okay? So chapter 16 is going to be digestion and absorption. Okay? So we'll kind of roll right into this one and get partway through for this lecture. Okay, so digestion includes these three different actions. Okay, mechanical action is going to be that chewing of the mouth, contractions in the stomach and the small intestine. Mechanical meaning, you know, by force. Okay, a grinding, some sort of a grinding action. So you think about chewing your food or the things that you maybe don't think about, the contractions of your stomach and your small intestine, kind of grinding things up and mixing things. Chemical action is going to be all the things, obviously, chemical. Okay, some of those are going to include the secretions of hydrochloric acid or HCl in the stomach, saliva, or the bile in the small intestine. Okay, so anything that's chemical related. The most obvious one, like I said, is going to be like your saliva. And then finally, enzymatic action, okay, is going to be when there's enzymes in different parts of your body that are acting on specific digestion of specific nutrients. Okay, so like the enzymes that are doing proteins, and we'll come back to enzymes here in a little bit. Okay. Three different diet classifications that you've probably heard of before. Okay, carnivores. Carnivores are going to be meat eaters. And those are primarily going to be like your dogs and cats. Okay, so not really a domestic livestock species. Herbivores are going to more refer to our livestock species, the veggie eaters. Okay, only eat plants and vegetables. Okay, those are going to be for our livestock species like our cows, horses, and sheep. Okay, and then we get down to omnivores. Okay, and remember, omnivores means both meat and veggie eaters. So that's going to be like us, humans. But the livestock species that you probably don't think about that's in this category is going to be pigs. Okay, pigs are actually considered an omnivore. Even though we feed them as though they're herbivores, pigs actually by nature are going to be omnivores and eat both meat and plants. Okay. So first we'll get into, there's a couple different digestive tracts that we'll talk about in this lecture. Okay. The first one is going to be the monogastric digestive tract. Okay. And the only animal that is a true the only animal that's going to be a true monogastric livestock species is going to be a pig. Okay. And they are the most similar to us. Okay. So we'll kind of go through each of their anatomy points here relatively quickly because it's pretty basic and it's pretty similar to our structure. Okay. So monogastric animals, obviously the first organ that food or feed comes to is going to be the mouth. Primarily that mouth is going to be, role is going to be reduce the food particle size. The saliva moistens the food and begins the chemical breakdown. Okay. Then we have this thing called amylase. Okay. And if you look down here, enzymes are going to be named anything that ends with this ASE. Okay. So amylase is going to be a starch digestion enzyme, okay, that's unique to monogastrics, okay, because we don't, or pigs don't, have the rumen to break down some of the starches. Okay, so remember that amylase begins the starch digestion. Okay, so coming back to this enzyme, a definition of an enzyme is going to be an organic catalyst that speeds chemical reactions without being altered in the reaction. Okay, so an enzyme is unique in that it can do its job and it can do its action, and then as soon as it's done, it can release it and move on to the next one. Okay, it's not altered in the reaction. Okay, so your body doesn't have to continue producing more and more enzymes because those enzymes are able to do their job and move on to the next one and keep doing that. Okay. So remember that anything that ends in ASE is going to be an enzyme. Okay. Some of the examples, okay, and you'll want to write these down. Okay, and they're pretty straightforward. Okay. The first one's going to be sucrase. Okay, SUCRASE. Okay, so sucrase is going to be an enzyme for sucrose. Lipase, LIPASE, is going to be an enzyme for lipids. So lipase and lipids. Maltase is going to be an enzyme for maltose. And lactase is an enzyme for lactose. Okay? And then of course up here, your amylase is going to be an enzyme for starch. Okay, so that one's the only one that's maybe not quite as straightforward. Okay? But anything, remember, that ends in ASE is going to be an enzyme. Okay? After swallowed, the food passes to the stomach through the esophagus. Okay, so the esophagus is essentially a transport tube to the stomach. Okay, there is some mechanical digestion that occurs in the esophagus, kind of as the esophagus squeezes and contracts the food down to the stomach. There is some mechanical digestion that occurs. At the bottom of the esophagus is what's called the sphincter valve. Okay, and that is to prevent food from coming back up into the esophagus. If you ever have heartburn, heartburn is actually a problem with the sphincter valve, or there's been a little bit of a leakage of the stomach components back up into the esophagus, and it causes that burning sensation. Okay, the stomach in a monogastric only has one compartment. Okay. And the important things that are in the stomach are going to be these four things, that HCl, mucus, pepsin, and gastrin. Okay? HCl, or that hydrochloric acid, it's going to be kind of that acidic environment. That's going to be what is producing that acidic environment in the stomach. And enzymes like acid. Okay? So that makes it a more favorable environment for the enzymes. Mucus, there's going to be a lot of mucus produced by the stomach. And that's essentially to protect the stomach lining from that acidic environment so you don't get ulcers. Pepsin is going to be an important component or digestive thing that's going to break down proteins into polypeptides. And gastrin, again, is for that enzymatic activity. Okay, and we'll pick up here at the next lecture.